We need to determine a point such that the tangents drawn from it to three circles, and the equation of these three circles are given to us, are of equal length. And we'll also need to find out the length of either tangents. So let us begin. Now, to find out the length of a tangent, let's recall the formula that we'll be using here. Now, let's say we have a circle which is centered at C with the coordinates -g, -f. And we have a point P, x1, y1, which is external to the circle. Then the tangent drawn from the point P to the circle at A, where the length of it will be given by PA equals the square root of x1 squared plus y1 squared plus 2gx1 plus 2fy1 plus c. Now here the constant g, f and c can be obtained if we write the equation in its general form. Okay, so let us begin. So here we will start with our first circle. We have circle 1. Its equation is given by 3x squared plus 3y squared minus 4x minus 6y minus 1 equals to 0. So let's say the point B, let P be the point with the coordinates. Let P be the point, and we're considering the coordinates be x1, y1. And PA be the length of the tangent drawn from that point P to circle 1. Now, in order to find out the length of the tangent, we'll have to find out the value of g, f and c. So let's use the equation of the circle, and then we are going to write it in the general form. Here we have the coefficient of x squared is 3 and the coefficient of y squared is also 3. We need to make it 1. That means we'll divide each of the terms by 3. So we get x squared plus y squared minus 4 over 3 times x minus 6 over 3 is going to give us 2. So we get 2y minus 1/3 equals to 0. Now when we compare it with the general equation of the circle, our 2g will be equals to -4 over 3. So here the general equation of a circle is given by x squared plus y squared plus 2 times gx plus 2 times fy plus c equals to 0. So here we have 2g equals to -4/3, 2f will be equals to -2, and the c value will be -1/3, which means g comes out to be -2/3. F value will be equals to -1 and the c value will be -1/3. Now let's find out the length of the tangent PA using the formula. So here we have the square root. We have considered the point to be x1, y1. So we have x1 squared plus y1 squared. Next we need 2 times g times x1. So here 2 times g, that's -4/3. So we have -4 over 3 times x1. Then we need 2 times fy1. So 2 times f, that's -2. So we have -2 times y1. And the constant value, that's going to be -1/3. So we're going to label this as number 1. Next, we go to the second circle with the equation 2x squared 2y squared minus 3x minus 2y minus 4 equals to 0. So here we're going to divide each terms by 2 so as to make the coefficient of x squared and y squared 1. So we get x squared plus y squared minus 3 over 2 times x minus y minus 2 equals to 0. Now what we'll do, we'll consider a point B on the circle C2 such that if we draw a tangent from the point P, x1, y1 to the point B, then PB is going to be the length of the tangent. So our goal will be to find out the length of the tangent PB. So here we have 2g equals to -3 over 2. 2f will be equals to -1 and the c value will be -2. So that means the length of PB is going to be equals to, we'll take the square root, we have x1 squared plus y1 squared, then we need plus 2g x1. So 2g is -3 over 2. So we have -3 over 2 x1. Then we have added to 2f y1. So here 2f is -1. So we have -y1 minus the c value, which is 2. So let's call it number 2. Next we go to the third circle. So we will convert this equation to the general form to get x squared plus y squared minus half x plus half y minus half equals to 0. So let C be the point which is tangent to the circle, C be the point of contact. The length then PC will be equals to square root of. So there's a nice and easy trick to find out the length of the tangent, all we have to do is take the square root and we'll consider the general equation of the circle, which is this form, and we'll replace the value of x with x1 and the value of y with y1. So that's going to give us x1 squared plus y1 squared minus x1 over 2 plus y1 over 2 minus half. So this is going to be equation number 3. Now it's given here that equation 1, equation 2 and equation 3 are equal. That means the length of the tangent drawn from the point P to each of the point of contact A, B and C are going to be equal. So what we'll do, we will equate equation 1 and 2. That's going to give us one equation, and then we can equate either equation 1 with 3 or 2 with 3 to get another equation. Solve those two equations to get the value of x and x1 and y1. Let us first equate equation number 1 and equation number 2. So here we get the two length equal to each other. We can square each other and then simplify this equation, and this is going to give us the simplified equation. X1 minus 6y1 will be equals to negative 10. We're going to label this as equation number 4. Next, what we'll do, we're going to equate equation number 2 and equation number 3. So that means we're going to equate PB equals to PC. So we get 2x1 plus 3y1 equals to negative 3. So let that be equation number 5. Now what we can do, we can solve equation number 4 and 5 to obtain the value of x1 and y1. Let's do one thing. So let's take equation number 4 and keep it as it is. So we have x1 minus 6y1 equals to negative 10. And then we are going to take equation number 5 and multiply throughout with with 2. So 2 times 2x1 will be 4x1. 2 times positive 3y1 will be 6y1, and 2 times negative 3 will be negative 6. We are going to add the two equations. So x1 plus 4x1 will give us 5x1. 6y1 and negative 6y1 cancels out. Negative 10, negative 6 adds up to give us negative 16. So x1 comes out to be negative 16 over 5. And using x1, we can use either equation 4 or 5 to find out the value of y1. We'll find out that y1 comes out to be equals to 17 over 5. So this is going to be the coordinates of the point P, negative 16 comma 5, 16 over 5 to 17 over 5. And this particular point is going to be, if we draw a tangent from this point to each of the three circles, circle 1, circle 2 and circle 3, then they are going to be of equal length.